I'm going to do a couple of table drawings here. Actually, we're going to do 2 for 1 here. They're both very similar to each other, 2 different floors of the same building. So before we jump into it, let's look at the packet in Packet Tracker here. And then we are going to apply our name to these. It's F69 and F70 for 6443 EY. So I'm going to throw those on my list real quick. And we're going to start looking at those. All right. So here we go. Markham is drafting, and we're going to get started here. So if you haven't already synced this project, please go ahead and do that. It's 6443 EY. And again, we are looking at 2 separate tables today, one on level 15, one on level 16 here. We have our ARC references here, which actually are the same. However, we're going to make sure that there aren't any differences when we get into it, because sometimes there will be a time where an architect may say similar for the ARC reference, and it may actually have a dimensional change or something that's not exactly the same, but similar to the point where they feel comfortable using the same section view or details. So what we're going to do is we're going to take a look at this drawing here real quick. I'll pull up the takeoff as well, and we're going to go ahead and dive right in. So let's split screen what we've got going here. Whoop. Okay, so EY right there, contract pricing, and I'm going to open up the takeoff here. And we're going to start digging into what exactly we have in our scope. Actually, before we do that, my apologies. This is actually a COR item. I don't know that I had it noted here. Oh, I did have it right here. COR1 packet. So COR stands for change order request. That is when something is added to a project after the job has already been released. So these items were add-on items after the job had already been started. So let's go into the COR1 takeoff here. And I'm going to look up these 2 tables in there. All right, give me a quick sec to bring those up. Okay, here's where we are. So we're looking for F69 and F70 here. Okay, so F69 starts right here and stops right there. So let's look at what we've got going on here. So we've got in our scope, looks like we have a plywood subtop, we have metal countertop support brackets, we have veneer paneling, we have framing in our scope, so we're going to build a drywall frame in this table. We have black metal base trim, it looks like, and we have purchase stone as part of our scope. So that's for table F69. F70, let's just check to make sure there's no weird things happening here. So same thing, plywood subtop, metal countertop support brackets, veneer panels, drywall framing, metal base, and purchased stone tops. So yeah, exactly the same for both. You'll also notice that the ARC reference is also the same for both in the takeoff as well. So without further ado, let's start looking at the architecturals here and doing our first once over on this. We're going to go to level 15 to find this first table. So I need to go back to the EY folder, drawings, architecturals, and level 15 floor plan. We're going to open that up, and then we are going to look for this community table. So a couple things you can do. One, if there is a floor plan with labels on it already in the folder, you may use that. This one does not because it's been updated since the original job kickoff, so there are changes to it, including removing those labels for now. So what we're going to do is we're going to look for this room here, 15.1079. So we need to go back to that floor plan and type that in. If you can't find it visually right away, what you can do is you can go over here in Bluebeam to the search option on the left-hand side. Go ahead and make sure that you are searching the current document. And you can type in that room number, 15.1079, and it will do a search through this entire page and pull up any labels that are the same as that. If you're still having trouble finding it, what you could do is click on this and then go up to the lightning bolt, and you're able to then change the color by highlighting, checking. So if I do that and I look over here, I can see there's a yellow box right here, meaning that this is the table right here that we're going to be drawing today. All right. So if you're looking at this, you can see that there is a enlarged plan view off of this view. So we need to find that. It's on page A4404. Let's go back to our drawings and pull that up. A4404, view number 6. View number 6 is right here. This one I had discussion with Trevor and Josh, the project managers on the job. There is something weird about this table that we think is a mistake from the architect standpoint. We're going to make the adjustment here, assuming that this is what they want. So the mistake that we're thinking is here is that this dimension and this dimension here normally would want to be the same. They're showing there's a difference here. Like this is a shallower depth. This is a deeper depth here. We are going to just draw it with equal dimensions on either side, but maintain the 12-inch die wall thickness in here. So just a heads up, when I go to draw this, that is something that we are going to intentionally modify here, and we're going to maybe make a note or something on the print to specify why we did what we did. So moving forward, let's try to find the level 16 table then too. So going back to the drawing folder, floor plan 16, and we need to go back to find our room number just like we did before. We're looking for 161163. All right, now I could do the same thing here and search for that if I wanted to. Search for that, check that box, and highlight that room. You see it popped up right there. So this is the room that we're working in. And again, like we talked about, there is a similar here. So be very cautious about that when you see that word on a drawing. If you see that, potentially there could be some changes because it's a similar and not the same, or similar and it's not referring to an exact drawing. So what we're looking at here is they're looking for a table that's similar to the level 15 table. But let's go ahead and pull this up anyway and to see if there's anything that tells us anything about the level 16 table. I don't think that there is any difference there. So from what I'm seeing, I think we'll be okay to draw them the same. I'm not seeing any dimensions here called out on this drawing or on this drawing either. So all the dimensions we're going to be working with will be pulled directly from that enlarged plan view here on page, A4404, view number 6. So assuming that these are the same, again, always want to be cautious about that because you can get burned by that if they are not the same and it just says similar, but it's really not. But assuming these are the same, since we're only given one plan view with dimensions, we're going to use that to make both tables. All right, so let's take a look at what we got on this page. So we got our plan view, of course. Our table is 15 feet this direction, 4 feet this direction. We have a 12-inch die wall in the middle, and we have a setback of 18 inches from that die wall to the edge of the countertop on the outside face of the table. This side of the table is butted directly to a drywall partition, which you can see that in your plan views here. That blue box there is your drywall partition by others. Same thing with this, drywall partition by others. And then there's your table in the middle. So let's go ahead and look at our elevation view next and see what we've got there. Okay, doesn't really show a ton, but it shows enough to get us started. So we've got solid surface 1 countertop. We have WD V1, which is going to be our veneer 1 or VN1 on our drawing. That'll be the panels around the die wall underneath the table. You can see we have a countertop height of 2'6". So we've got that noted. And then we need to look at this section view 5 on the same page here. Okay, so view 5, you can see what they're looking for. They have the die wall somewhat detailed out. Typically, you're not going to exactly match what they have there. We're going to build our own die wall framing, and we have blocks for that, so that helps with that. And if you do want to learn more about die wall framing, there's a separate video for that that you can go back to if you'd like to. But yeah, we'll just kind of use this as a reference. So we know that there's a die wall in the middle of the table. Looks like there's going to be some kind of an outlet built into the top and outlets built into the sides of that die wall as well. So anytime you see a die wall with outlets, well, pretty much a die wall at any rate, but specifically anything with outlets or any holes cut into it or anything like that, you probably want to make sure that one side of your die wall is removable. Just so you can get access to the wiring in case the electrician needs to get in there, or if something ever breaks over time, then there's the ability to get back in there to maintenance the electrical in the die wall. We're going to talk more about that when we get to that later, but you can also see in this view, which they neglected to show in their elevation view here, but there is a small strip of metal base below these panels. It's shown right here, though. It's only 1 inch tall. It's probably why they didn't show it, but they really should have, because it still should be visible there. But either way, we know that it does exist. We have it priced on the takeoff, and it's shown here, so we know that it should be there. All right, so let's talk about, let me look at this real quick, make sure there's nothing else to go through here. Okay, so one thing I'm also going to do is I have already drawn a table similar to this on this project as well. So I want to match the style of what I did on that table. Normally I wouldn't really recommend kind of using another drawing as a reference for training purposes, but since these tables are both part of the same job and one of them's on the same floor, we do want to make sure that they do match the same style. So let me pull that table up here. Here it is. Okay. So this is a similar table on the same project. I want to show you a couple things on this before we move into actually getting into AutoCAD here. So this table does not butt into a wall. This one's actually free floating in the middle of the room. So that's one difference between this table and the table that we're going to be drawing here. The other difference too, that's the same base trim, so that's kind of helpful. But one thing that is not shown on the architectural drawing for our table, and it wasn't for that table that I'm referring to here either, is whenever you have panels, or any material really, but panels, you want to start to think about what you need for material sizes. So general rule of thumb, whenever you're dealing with panels, you don't want to exceed a panel that is 4x8 or 48 by 96 inches. That's just kind of a general rule. Anything larger than that, sometimes it's okay. It depends on the application and getting it through the building, and if the material is available in sizes larger than that. So when we go to draw this, we know that we're not going to be able to draw these panels going all the way across here without any breaks in them. So just like what we did here on this other table for this project, we put in 1/4 inch spline reveals in between these panels. So we're going to be doing the same on the other table so that these match up and they look consistent. Take note of where these spline reveals are located too. There is some areas here that we do want to match, like specifically here, where this radius portion meets the straight portion. We put our spline reveal right in between the two, there and there. And then the same thing on this side as well, because it's a lot more difficult to make a panel that curves and then flattens out. So what we're going to do is we're going to break it where the curve stops. And then the rest of the spline reveals are going to be equally spaced in between, as you can see based on this elevation view here. They are not exceeding 48 inches here, but what we got going on is we have equally spaced spline reveals. One last thing before we get into CAD. So tables and islands, you can support these several different ways. When you have a countertop with a cantilever like this where it overhangs and overhangs, even if it's just one side, you want to start to think about how am I going to support that. So one thing that you can always do is there's a vast selection of different brackets that you can buy online to support countertops that overhang like this. If you are looking for a bracket specifically for an island, a really good one to use would be this A&M island bracket. It is essentially flat bar steel, which just sits. I'm going to pull up the drawing or the picture of it so you can see it. So essentially what it is you have a flat bar of steel that's 1/2 inch thick. It gets routed into either your subtop or your ribs. In our case, we don't have a subtop because the stone is right to the top of the die wall. And you can do that when you have a 3 centimeter stone top. In this case, that's what we're showing here. If there was a subtop here, I would rather route the bracket into the subtop than route it into the top of the die wall like this. But we don't have a subtop on this, so we're going to route those brackets into the top of our die wall like this. So very similar to what they have drawn or photographed here on their website. We're going to have that bracket cut into the top plate of our die wall like this. All right. So, and then that bracket will span across both sides of this overhang. Now, just because that is one option does not mean it's always going to be the right option for islands. There's other brackets that they offer as well. Considering like if you had a one-sided island, or maybe you want to support it a different way if there's a reason that you can't use that one flat arm bracket that's straight across, you could potentially use one of the C flat brackets. Like the C flat 2.0 brackets are a really good option for a lot of islands like that too. All it is a steel plate that bolts into the ribs inside the die wall, and then it has an arm that sticks over the top. So again, this is not right or wrong. In fact, it's kind of more opinion based, but you can do this or you can do an island bracket for what we're doing today. I'm just electing to use the island bracket because it's a little easier. I feel like it's less to have to deal with coordinating where the bracket goes, machining and everything. It just sits right on top of that die wall, and we route it into the top of the die wall, and then that's all you need. So, sorry, one more thing. So, as I mentioned before, when you're dealing with a die wall, it's always, always important to remember that usually you're going to need one side to be removable. One side can be fixed, or both sides can be removable. So the key thing here is that when you're building a die wall, typically at least one side needs to be removable at all times. That's not just to get access to the electrical, but also to be able to construct the die wall too. Because if you can get in here, it makes it easier to actually frame and build this thing without putting face fasteners like screws through the front like this, because you don't want to do that. So what I have drawn here is I have panel cleats on both sides of the island frame, and we're going to use that on our island as well. You could also potentially use integrated cleats here if you'd like to, that are routed into the die wall framing. We did talk about those during the die wall framing video too, but you can do that too. I would say one thing to always kind of take note of is anytime you have a bracket that hangs down below your counter like what we have here, and you have a panel that's removable that's below it, always be mindful that no matter what, you need 3/4 of an inch lift-off space for these panel cleats to be able to work. So right now, my dimension for my reveal is 1.25 inches. The reason for that is this bracket is a 1/2 inch thick, plus I have my 3/4 inch lift-off space. So I have 1.25 inch reveal technically whenever there's not a bracket. So looking back at the elevation view, anytime there is a bracket, this is a 3/4 inch gap. But anytime there's no bracket, that's 1.25 inches there. And that's just to be able to make sure that this panel can clear that bracket when you have to remove it. So always, always important to remember that. And again, that's only if the bracket is hanging below that subtop there. But always make sure you have enough room for that panel to lift off. Okay, so let me go ahead and close that. And we're going to start looking at this table here. So let's go ahead and get CAD fired up. AutoCAD 2026. By the time you watch this, it may be outdated, but we'll see. So while that's loading, I'm trying to think if there's anything else to really discuss on this. We might be okay. Yep, we got our radius corner. Actually, it's not shown here, but let's assume that it's the same from this table to this table because it is in the same building. Most likely, they're going to have the same design for both. So, okay, there. Oh, still loading. Geez, that thing's taking a while. Okay. How are we doing? Still loading. Goodness gracious. Well, that's going. I'm going to split screen our what we're doing here. Okay, there we go. Kind of, sort of. Sorry, it's glitching right now. Ah, there we go. Now we're cooking. All right, so let's go ahead and we're going to find the template file for EY. Should be right in the prelim project folder. So let's go back to there. EY drawings, prelim project, and we're going to go to should be a red icon there, .dwt, EY drafting template. I'm going to open that up and we're going to start working here in CAD. Okay, bring that drawing back over here and maybe I'll give myself a little more room over here on CAD. All right, so depending on the drawing, it depends like what you want to do. I kind of like to start with my plan view most of the time because it's my base view. Other times I may work backwards and go section view, then elevation, then plan, but I'm going to start here with the plan. Making sure we are on the geometry layer. We are going to draw in a rectangle that is 48 by, let's see, what is 15 inches? 15 inches, 180. So 48 by 180. So I just, here, let me make sure I explain that a little better. So you can either type in rectangle or you can go up to your menu and you can pull it from there. And when you go to draw this, it's going to ask you for your base point. So click anywhere there. And then it'll ask you for 2 dimensions. So first dimension, 180, which would be our 15 feet. I'm going to hit my tab key on my keyboard to switch over to my secondary dimension. And we're going to type in 48 inches for that. All right, this is our rough outline of what we're doing here. So if you remember, there is a radius corner. Looks like it's 4 inches radius. We're going to match that on this table. So let's go ahead and draw that in. So we're going to go fillet, R for radius, and then 4 inches. And it's going to ask you for 2 objects, first object, second object. I'm going to hit enter to restart the command. R to check my radius, set to 4 still, great. First object, second object. All right, so now we've got the outline of the tabletop itself. I would like to draw in this hidden line just for reference for right now of what that die wall shape will be. All right, and we know that it is 12 inches wide, and we know that it is 18 inches short of the 15. So we're going to go 180 minus 18, meaning that our die wall should be 12 inches wide by 162 inches long. So we'll draw that in here at 162, tab, 12 inches, enter. Okay, move that die wall to where it needs to sit, centered right below that table, because as we mentioned before, we think this might be a mistake. Confirmed it with the PM. We're going to pretend that it's just a centered die wall. So fillet this corner. It's hard to see here. What we ended up doing on the other table we referenced earlier is we made this a perfectly round corner. So we know the die wall is 12 inches wide. So when we go to fillet this corner, we're going to fillet it with a radius of 6 inches, so half the diameter of this die wall here. There we go. Should give you a nice perfect circle right there. All right. Now, if I really wanted to, I can make this a hidden line because really that's what that needs to be. And then we're going to take this and we're going to move it right to here. I'm going to take my corner using the move command, and I'm going to place this geometry right at the corner of my grid like this to be in square with everything that I've got. Then we want to do, now that we got the plan view drawn, and maybe I can even add the die walls in, so I need to open my tool palettes here, go over to my annotation tab, and we're going to pull in the floor hatch, which we're going to use as a wall. Okay, so once that's loaded, let's rotate it so it's facing the correct way. I'm using my ortho snap here, my F8 key, to make sure that my block does not come in at a funky angle. And then what I'm going to do is just offset this, well, or sorry, not offset, that's a bad choice of words. I'm going to move this up about maybe 12 inches or so off the face of my drawing. So that way I can show that the wall does continue past the table on both sides, which we can confirm with the floor plan that does happen. This wall continues quite a bit off the edge of the table, this way and this way. And then for level 16, it is the same deal. It continues that way and that way. So for right now, that's what we've got for our plan view, and we're going to leave that alone. We're going to move on to our elevation view next. So let's go ahead and copy our plan view down to our elevation area. And then we're going to start to pull some construction lines from that. So draw some lines straight down. Again, when you do your construction lines, there is no rhyme or reason to how long they need to be. Just make sure that when you draw them, that they are extending past where you need them to go. So that way you can delete them easier later on. All right, so let's do some investigating here to make sure what we've got for materials is the same as the other table. So we know base of it is VN1, veneer paneling 1 or veneer 1, and then we've got SS1 for the countertop. So we need to go into the on-site material log within Airtable, and we're going to look up what that is. So we need to know what our job number is. So again, EY is 6443. Let's go down to project 6443. Right there. Okay. We need to find SS1. So there it is. And actually, paying close attention, the on-site call for SS1 is actually QZ1 because this is a quartz material. Let's see, this is 2 centimeters. So actually, this is a little bit different than what we had drawn previously on the other table. So what we're going to do is we have to modify that design just slightly here. Okay. So when it comes to 2 centimeter stone tops, you always want to make sure you have a subtop below that stone. 3 centimeter is thick enough that you can get away without having a stone or a subtop below. But 2 centimeter is too thin and become brittle, and you want to make sure that you have it supported so it does not crack or break. So what we're going to do is we're going to put in a subtop below that stone to support it better. And then we're going to put those brackets in just like we had before. The only difference here is those brackets are going to be routed into the bottom of that subtop rather than into the top of the die wall. So let me get to the section view. We'll talk more about that here. Let's go ahead and start with some more construction lines for the vertical dimensions. So right away, we know that our height from floor to top of counter should be 2'6". So we're going to offset this line from the floor up 30 inches. That's our countertop height right there. All right. And then solid surface 1, again, that's QZ1 for us, but it is 2 centimeters thick. So what we're going to do is we're going to draw that as if it's a 2 centimeter top, meaning that the stone should be measuring out at 3/4 of an inch, plus we're going to have a 3/4 inch subtop so that the front edge of this should read at 1.5 inches high. So I'm drawing in a rectangle. I started with this corner up here, dragging my cursor across, and just like our plan view, our overall width is 180 inches. So let's make sure we match that. We'll hit the tab key, and we need to bring that down towards the floor 1.5 or 1.5 inches there. All right, now that we have that, I also need to draw in a rectangle to represent the panels here. So let's do that. Snap it to that corner there, snap it to this corner there, and then we can start to delete some of these construction lines because they are no longer going to be needed. We can throw in the floor and wall hatch to represent where the floor and the wall meet. So again, I'm going to show this extending past ever so slightly, so that way we can tell that the floor does not stop at the edge of the table, it actually continues on. And then we have 32, and I'm extending it 12 inches past. It doesn't necessarily matter so much, but I'm keeping that dimension consistent from plan view to elevation view. So I extended my wall and floor hatch 12 inches past the edge of my drawing, just to represent that it continues. It doesn't stop right there. All right, now from there, what we need to do is we need to take, oops, sorry, jumped a little bit over. What we need to do is we need to take this view and, well, I guess I should leave that plan view in there. Let me move that over with it as well. We're going to take these two views together, and we are going to then put in our spline reveals. So like we mentioned before, we want to break up the curve from the straight panels. So we are already planning on putting a set of spline reveals right there. And then we're going to equally space the rest of those reveals all the way down the line here. All right, so let's go ahead and let's offset this line. I'm going to offset it 0.125 in either direction off the center. So that way I end up with a 1/4 inch reveal at this specific location here. So I'm bringing it in 1/8 into the curve, 1/8 into the straight panel, and that gives me that 1/4 inch that I'm looking for there. Then from there, I'm taking a line from the center of that reveal, and I'm moving it over here to the wall. And one thing that I'm thinking about doing here too is I want to also put a reveal to this wall because it's unlikely that like the wall is going to be completely flat. So it's a good idea to break up the panel from the wall so that way it doesn't have to match up spot on with the wall, because if the wall is kind of like wavy or curvy at all, you're going to read that really bad against our panels, and it may even look like our panels are the things that are out of whack. So I know I'm doing 1/4 inch reveals in between these panels from panel to panel, but I want to do a 3/4 inch full depth reveal at this location. That way I can bridge the gap between the drywall and our panels here. So when I do that, I need to draw in a imaginary line temporarily. That's 3/4 inches wide. So again, just checking that. 3/4 from the wall to the line there. All right. And then in order to do an array path, it's important to remember that you're always going to measure from center of reveal to center of reveal on the opposite side. But this reveal is wider than the reveal that we're starting with, so that's going to throw us for a curveball here. How we get around that is we're going to go and bring this line to the edge of this reveal, even though it's a different width from the reveal on the other side. But we're going to imagine this is a 1/4 inch reveal that starts here at this line, or where the other reveal meets. So let's bring this over, 0.125. That's half the distance of the reveal. Or no, I'm sorry. Yeah, that's half the distance of the reveal. So when you think about it, the front of that reveal, the imaginary one, starts here. And when we array this, it's going to put the other part of that reveal there. And then we're going to end up deleting this one anyway. But the reason why this is important is because this is the stop of the panel. And we're telling AutoCAD where that panel stops by bringing this out that 1/8 of an inch, or half the width of the 1/4 inch reveal. Let me make sure I got this right too. I just don't want to make sure I messed this up. I did. Okay, I got it right. Okay, so now what we got to do is we're going to take the array path command in AutoCAD, and we're going to highlight the front and the back of those reveal lines. We don't need the middle. We can highlight it, but we're just going to delete them anyway, so you might as well not. We're going to highlight the front and the back of the reveal, hit enter. Then we're going to select that path that we made that goes from center of this reveal to center of the imaginary reveal on the right-hand side. When it starts out, you're going to have a random amount of reveals placed in here. That's perfectly fine. You're going to go up to your toolbar that shows up at the top, switch it to divide. And then you're going to adjust these number of items until you get to a place where you know you can make these panels work. So as mentioned before, I don't want to make my panels any larger than 48 by 96. So what I can do here is I'm going to try to find a magic number that works. Right now at 3 panels or 4 reveal lines, I have a panel size of 51 and roughly 3/4 of an inch. I want to get that down a little bit further, so we're going to go 5 reveals. And we're going to go 1, 2, 3, 4, 5 reveals, which means 4 panels. And that brings us down to 38 and some change, which is a lot more manageable than doing a 50-something inch panel. So we're going to hit close array. We're going to explode those lines there. And then we're going to extend these down to our floor line here. Just like this. Okay. And actually I should extend down the 3/4 inch full depth reveal here too. All right. So again, now that we're done with that, this plan view, since it's not our actual plan view, can be deleted. We're going to delete those. Oh, no, sorry, we're not going to delete those. We're going to trim those, sorry, to the bottom of our subtop here. And then we want to throw in our 3/4 inch reveal at the top here too for the liftoff space. So we're going to bring this box down 0.75. And we're going to trim these lines one more time. Sorry about that. I should have caught that earlier. Trim these lines back to here. Okay. That line's extra. It doesn't need to be there. Okay. So you can see that reveal there. Now, this counter isn't floating like it's shown. So what we need to do is connect a line from here to here. And we're going to move that line back 3/4 of an inch, so 0.75. That way it represents that there is a reveal block sitting behind the panel. All right. Now, one last thing that we need to incorporate is the metal base. Metal base, I believe they had it drawn at 1 inch tall. So we're going to draw that at 1 inch tall on our drawing as well. All right. 162, 1 inch tall. And it looks like it sits. Let me just see how I drew this previously on the other table too. Did I have it sitting behind there or right below it? Right below it. Okay. So if it's sitting right below the panel as they have it drawn, then what we really want to do is we want to bring this in about a 1/2 inch, I believe, because I think it's a 1/4 inch piece of metal, if I remember right. It doesn't really call it out, but that's what it looks like. So I'm bringing this in a 1/2 inch because our panel is 3/4. So that means that it's sitting right there below our panel. Okay. I'm going to bring this line up to the top of that metal base. And then I'm going to trim the reveal lines out so that they don't go through the base trim because we don't want that. Okay. Just like that. The base should always run through. Reveals and fillers always stop at the top of that base. Okay, so elevation view wise, this is practically all we need to show. So we're good with what we have there. What we're going to do next is we're going to draw our section view. That section view isn't too difficult to draw, but we're going to take what we know from our plan view and what we know from our elevation view to be able to draw that. So what I mean by that is we're going to use the elevation view for the heights, and we're going to use the plan view for the widths. So go ahead and start by drawing in construction lines straight off of that. Just like this. Okay, now we need lines coming off of our elevation view, so that way we can start to build our grid. I'm just going at every meaningful point. So now what you can see here is we have this crisscross grid of what's happening. Oops. Okay. Jeez. Okay, there we go. Sorry about that. It's kind of hard to see on my little screen over here. But we got this crisscross grid of what our section view will look like. Okay. So our new countertop block will actually allow you to use this for islands. So we're going to go to casework, cabinet parts, and we're going to go to countertop here to insert a countertop block. It's going to take me a second for it to load. I haven't used this one in a minute. But once it drops in, how to use this for an island is, of course, an island is going to have a finished side on the back and the front. So the first thing you can do is either go in through the drop-down menus, or you can go over to your properties pane, and you can tell it you do want a back apron, which means that it's going to have a finished face on the back and the front. All right. Now, because this is furniture, I'm going to change this to a full subtop. So no strips. We're going to make this one full subtop all the way across. And then we're also going to change the material from 3/4 of an inch to 2 centimeter stone. All right, or 2 centimeter quartz in our case. We won't have ledger and we won't have scribe. Those are only used when you have a countertop up against a wall. So what we're going to do now is we're going to locate this right there on the drawing. Go ahead and use the grips to resize it. Oops, hold on a minute. Missed the point. There we go. Resize it to what you need it to be. There you go. Got a nice countertop there for your island. Now, we need to draw in our die wall. So it's going to support our countertop. So we're going to go down to the die walls portion of our tool palettes here. All right. So the other drawing that we referenced earlier, we put cleats on both sides, which we can do here as well. So we're going to use the die wall that shows hang cleat and hang cleat on both sides. So we're going to flip that over here, bring that in. All right. And we need to move this over. So 0.75 in from that side. And the same thing for this side as well. I also need to bring this in 0.75 because we need to get this ready for our panels to sit on top of. Because these two lines are the finished face of that die wall, meaning that's where the panels actually need to go when the die wall is done being built. So now what I'm going to do is lower this die wall so it sits right below that countertop, just like this. You can see there, now I've got my countertop, my subtop, my die wall, my cleats. I need to add my panels to this, my reveals, and then the metal base at the very bottom. And then other than that, it's just fine-tuning detail work of adding the outlets in. So I'm going to start by drawing in those panels. So starting here, this is the bottom of the reveal line and the front corner of my panel. And I'm going to take that and align it here to the bottom of my locator plate at the bottom of that die wall. We are going to have to move that later, so it's fine to leave it where it is for right now, but just keep in mind that we do have to raise that up 1 inch, which I guess I could do that right now. Raise that up 1 inch, so that way we have room for that metal base. All right, now we got all of that. We can start to remove some of these lines because they're not even needed anymore. Those go away. These can go away. In fact, these can go away, but I'm careful not to delete my grid by mistake, so I'm unchecking that. And then my panels here, I'm going to hatch those appropriately. So I'm going to go back to my annotation tab, grab my my MDF vertical hatch, and drop those in those panels there. Okay, so then the last things we need are the reveals and then the outlets, detail work. So easy stuff. So reveals for something like this, what I'm going to do is I'm going to make a reveal block that is 3/4 thick and 1 inch, or no, let's go 1.5 inches tall. All right, we want it to be taller than the reveal, but I'm going to resize it a little bit to fit there. I want it to be taller than the opening, so that way there's not a gap here at all. So we're going to make one of these on this side as well. So one on either side, just like this. Okay, and then we need to make that metal reveal at the base. So again, I will reference our old drawing for this because I just need to see what we did. Not entirely sure how we did this. So let me measure that base and see what that actually was. Is it really 1/8 inch thick? I suppose it could be. That does look pretty narrow, but okay. So if it's an 1/8 inch thick, let's go ahead and draw that in. So we know it's 1 inch tall by 0.125 thick. Just a real thin metal band that sits right below the panel here. Just like this, we'll use that metal hatch, drop that in, and we're going to copy this over to this side as well. Make sure that we get it located correctly using the move command to snap it to a corner like that. Okay, so there is the essentials of what we've got going so far. We're going to talk about outlets, brackets, and then we need to also incorporate a wire chase into this die wall so the electrician has a place to run wires through the die wall. Let's start with the bracket first because the bracket is by far the easiest of this 3 things that we have here. So we're going to go to on-site hardware in our tool palettes. We're going to go to brackets, and we're going to pull up the, A&M island bracket right there. Oh, sorry, island bracket. I clicked 1 too low. All right, island bracket here should look something like this. We're going to set it to be through the section, elevation view, so we can see the side of it. And you can see it is in 3 separate options here. We have a 34, a 40, and a 15-inch bracket. Now, let's be mindful of where we're doing with this because we want to make sure that it does fit in here, but we also want to make sure that it has at least 2/3 of this overhang covered. Anything less than that, it starts to become a little bit less stable. So what I'm going to do is I'm going to check to see if I go to 40 inches, it does not interfere with the stone and it's not going to get too close to the edge, but it's going to cover way more of this cantilever here, or the overhang. So you definitely don't want to go 15 because 15 is not going to do you anything there. 34 may be okay, but 40 is definitely going to support it well enough. So we're going 40 inches wide for the arm of the bracket. You can see what I did differently from the other drawing too, is I actually routed this into the subtop. So we're going to do that for this drawing here. Because we do have a subtop, we can hide that bracket in there. So you won't see it from the front like the other drawing. And also you won't have any clearance issues with your 3/4 inch reveal above your panel. So we're good on that. All right, moving on. Let's see what else we got here. So let me bring back my Bluebeam here. Sorry about that. We have outlets to add. And we are also going to add in, the wire chase too. So outlets are real easy. You want to kind of make sure you have them exactly where they want them. So we're going to go to on-site miscellaneous to pull those outlets. There's several different variations of those. Doesn't matter if you pick the wrong one by mistake, because if you do, you can always toggle it to show the correct outlet that you're looking for. So right now that's an internet port. You can change it to single electrical port. You can change it to a light switch if need be. There's all different options in here. If you need it for something, there you go. We just need the outlet though, I believe. See, outlets are not drawn on their elevation view. So what we need to do is we need to see if we can figure out where those are and how many of them there are too. So to do that, if you're looking for anything electrical, there is a set of electrical drawings that exist for each job. Now, if we have it in the folder, that's great. Sometimes we don't always have them. So we're going to see if we have them here. I do believe EY does, fortunately, so that does help. So let's go to the trade shop drawings and see if we can find that. So we have equipment, we have lighting, we need, really what we're looking for is electrical power. Oh, there we go, electrical power plan. We got 15, level 15 and level 16 here. So we're gonna pull those open and we're gonna see what those show. All right, give me a sec here, get those loaded. All right, so starting with 15, because that's the table we're focused on right now. All right, here's our table. Sorry, it's loading still. Okay, this doesn't actually tell us heights of those outlets, but it does tell us something else because there were outlets in the tabletop. All right. And those outlets appear to be something called E1-18 or /18. There should be a schedule. It's not on this drawing, but there should be a schedule in the electrical drawings that explains what E1/18 is. So we're gonna find that. Sorry, I gotta dig through here real quick. No, not that. Not that either. We're getting closer though. E1-19 is conveniently skips right over 18. Look at that. And it was 18, right? Yeah, it was. Well, that's actually for the circuit breaker panel anyway, so that's not exactly what we're looking for. I'm looking for specifically if they have some kind of a almost like a finish schedule, but for the electrical outlets on the project. Sometimes they'll have something like that here. And if they have a like an abbreviation or a call out to something. That's kind of a key giveaway that you're looking for. You're looking for a schedule. No, it wouldn't be that. Hmm. Well, I suppose I can keep looking for that, and we take a break here, see if I can find that. I wish it was right here, or I wish I just saw it, but I'm not seeing it in here right now, and maybe I'm just overlooking it. So, not to kill any time, I think I can come back to it and see if I can locate that for us here. Unfortunately, I'm just not seeing it right now. Yeah, sorry about that. I will find it though, and we'll get that going though. So let's skip over that for just a moment. That's other people's scope anyway. It's it's important to show it, um, but um, but we can come back to that. Let's go back to our drawing here and see what else we needed. So we needed the wire chase in the framing too. So Onsite has very specific regulations for that, or standards for that. I'm going to pull up a schematic for those right now that I can talk through it with you. It's also part of our Dywall training video too, but we're going to talk through this here. So this document does a very good job of explaining the different components of a Dywall. So if you are unfamiliar with those, you might want to go back to that video. And if you are familiar with those, that's great. But we're just going to brush up on the wire chase aspect of that. So what you can see here is our current standard for a wire chase is we want to have at least a minimum of 1 inch from the edge of that wire chase to the edge of the rib, meaning that this hole cannot be larger than this or it will start to compromise the structural integrity of that rib. So we need at least 1 inch of plywood in this here. And this circle is a hole punched through there so they can run wires through the Dywall. Okay, and you can see that here in this 3D view as well. So what we're going to do, we're going to go back to our drawing and we're going to make sure that we do not exceed that 1 inch mark. So let me just make sure that there's not a specific minimum for the hole on here as well. I'm going to scan through this real quick. Make sure it's not noted anywhere. Okay, cool. So what I would like to do then in this case is I want to probably make this 1.5 inch diameter hole. So we're going to go, well, maybe 1.5 radius, so 3 inch diameter hole. That gives us plenty of room here. We're not going anywhere close to the edge of that rib. We still have 3 1/16 inches before we hit the edge of that rib, which is fine. What I'm going to do is I'm going to use the array path, and I'm going to go from the center of that circle, which is the middle of my top plate on my Dywall, to the middle of the top of the base plate on the Dywall. Confusing, yes, but that's what we're doing here. So we're using the array path now with that line we just drew. And we're going to divide this out so that way we are, let's see, there we go. All right, so we got, I went with like 3 separate holes that should give them ample amounts of space to run wiring through there if they need to. Plus the hole diameter is large enough that it should not give them any problems at all. Let's come back to those outlets in a minute though, because I wasn't able to locate those on their drawing here. So it's possible that this table actually may not have any outlets on the front like the other table did. So based on the millwork side of the scope, not even considering the other trades like the electrician right now, what we have here is exactly what we would be providing for the client. So this is our stone quartz top SS1, QZ1 is what we're going to call it. We have our plywood subtop, which we are going to call out as PRBLK later for primed black. We don't want that to be exposed plywood. We want it to look nice and finished. So we're going to prime it black. You have our VN1, veneer 1 panels that run along the sides of our island table. And then we have our VN1 reveal that sits right above. We also have our metal base, which sits right below that panel too. And then going through the components of the die wall, just as a refresher for you here, we have our top plate, which is a 3/4 inch plywood top plate that runs the entire width of the rib. We have what's called the ribs or the studs, which are these vertical components that sit in between the top plate and then the base plate. The base plate is the next step, which we got here. That is a 3/4 inch base plate made out of plywood. And then you have a 3/4 inch locator plate, which sits on the floor. The locator plate will be installed prior to the island or the table being placed in the field. This allows the install team to be able to locate that without the furniture actually being over top of it. So they'll attach this down to the floor using some Tapcon screws to drive right into the concrete floor below. Then this gets mounted right over top. And one important thing to note too is that that locator plate does actually span all the way from left to right of not only the rib, but any die wall components that are there. So right now we got cleats on both sides, and this pad is going all the way to the front of that cleat on both sides. All right, so quick refresher on die walls. And then of course we already talked about this, but you have your wire chase holes that run through here. So those are all placed right there and they'll be cut out before this gets out to the field. All right, so let's move this view down to our section view. Down to here. And we're gonna place that right there. Okay, you can delete this plan view here, it's no longer needed. But because we use construction lines, every one of our views should be in line with one another, and they should all match up dimensionally with one another as well. So we are doing really good there. All right, so the only thing left before we get to plotting our drawing is we're going to need some details here. We will need a detail of the spline reveal in between the panels. We're also going to need a detail of the 3/4 inch full depth reveal where the panels meet the wall, like the drywall wall over here. You shouldn't need any other details for this particular drawing unless you want to maybe make a blow up of this here because this is very small and it will be very hard to dimension that otherwise. So we probably need to make a blow up view of that as well. Otherwise, this view, this drawing shouldn't really need much more than that. So we know we need 3. We need a reveal, we need a reveal to the wall, and we need a metal reveal to the floor. So lots of reveals. Oh, and let's go ahead and add in that floor hatch here too. All right. There we go. Cool. I guess I could probably make those details real quick before we take our break here in between prints. So real quickly here, so details for panels. You will be able to utilize some of these from your panel details up in here. We could draw this out by hand too, or we could use this up here. So we got a spline reveal, which is here. What it is you have an 1.25 inch wide piece of material by 1/4 inch thick, and it's going to sit right nested in between the 2 panels. And the 2 panels will have a route carved into them to receive that spline. This detail here, we will have to explode it because we do need to modify it slightly to show what's actually happening here. This is not going to be drywall, which is what's shown currently. That's drywall and batting insulation, which is not accurate for what we're doing here today. So I do need to clean this up to look a little different than what we have right now. So to do that, a good thing you can do is take what you've got from your section view here. We can copy that. Again, you're seeing a reoccurring theme here because this is something that is really going to help you out as far as making sure everything matches up. I'm going to take that section view, we're going to rotate it on its side, and then we're going to take the front of those panels and we're going to line them up with the front of the panels in the detail here. Okay. Then what I want to do with that is I want to take a line from here to here to represent the gap between the panel and the framing. Okay, so we can trim that line around that circle there. And then we want to do with that too is we're going to show the ribs a little arbitrary because I'm not modeling this right now. I will do a secondary video where we do model this table too, so you can use that as a practice one as well. But what I'm going to do is I'm going to show a double rib here. And then when you're thinking about die walls, the standard really is anytime you have a rib, typically the distance is going to be at 16 inches max. So you don't want to go any more than 16. You are more than welcome to go less than 16 in between ribs. Don't get too carried away though, because you don't want to end up with a wall with like 6 inches between ribs, because that would just be way overkill and eat up a lot of plywood material. So I'm doing a double rib here because at joints in a counter, you typically will do or joints in a piece of furniture, you will do 2 ribs back to back where they can attach them together and fix those 2 pieces if they're coming in multiple parts. So I'm showing those ribs there by representing 2 3/4 inch pieces of material back to back, just like that. So that should do it for that reveal. We also need to come up with a reveal here at the wall. And so that reveal is going to end up being, let's see here, I copy this down to here. And we're going to kind of draw this one in, just like we did with this one, except we kind of cheated on that one and we did it without having to fully draw that out by hand. This one I will have to draw out mostly by hand, and that's okay. Sometimes it happens that way. So we're going to offset this dashed line in 0.75 because that is the start of our panels here. And then what I'm going to do is draw in a rectangle just like this, making sure that it is 3/4 thick, and it can be whatever distance it needs to be. Let's see. I'm going to erase some of these lines here, and we'll trim this back to there. Okay, and then we know that there needs to be a 3/4 full depth reveal here between the wall and the start of our panel, so we're going to shrink this panel in 0.75 to make that work. Okay, and then we'll also remove some of these extra lines. I'm going to explode the wall hatch so I can trim that to fit within that circle. Like that, nice and easy. And then the last thing for that is we need to hatch and we need to add the full depth reveal block. So again, like previously, we're going to take the section view, rotate it on its side, move that so that the panel is in line with the panel on our detail, just like this. And then we are going to take, which I guess I could have just done this too. That would have been a lot easier, is take that reveal block and just paste it in right there. Let's throw in some hatching for that. And then I'm going to drop in one more rectangle here, which I'll trim back to here. And then we need to drop in 1 rib in between the wall and our die wall that we're building. So that rib, again, just like everyone else, is 3/4 inch thick. And it's going to extend past my detail, so I'm just going to trim that out like this. And then I'm going to hatch that with the plywood hatch like this. So when you get to that corner, that is what that full depth reveal will look like. It's going to be a full depth block that sits behind the panel, and then your panel is going to stop short of the wall by 3/4 of an inch, just like this. Let's take this detail and we're going to move it down to here with our other views. And I'm just going to move it a little bit off to the side so it doesn't overlap at all. All right, last one. And then we will take our break. And in the next video, I want to try to model this, which I know is kind of a step backwards, but I wanted to kind of showcase what the island needs first. Normally, you wouldn't want to do that. You just want to model it right off the bat and then go in and plot off of that model. So this is kind of a little bit stepping into the modeling aspect of it, but let's go ahead and do this. So we're taking our section view. I just made a circle around the thing I want to be a detail. And I need to take anything that's within a block currently and explode it so that way I can trim everything back to that circle that we just incorporated into the print. So that circle is there. We're looking good. I'm going to bring that down to here. And I'm going to align this with oops, sorry, I gotta readjust that a tiny bit. I'll align this with the side of our bubble here, and then align it with the baseline of our grid right there. Just like that. So we got our 3 details now. We'll dimension and tag those later, but right now they're all set up here in CAD. You can see I got my base trim, I got my full depth reveal, I got my spline reveal. I got my elevation over here and my section. We only need one section for this right now. When we do the model, I am going to make a horizontal section with you of this island so you can actually see where the ribs are going to go and how that all comes together on the inside. Elevation view, technically we should probably make 2. I know it's exactly the same from one side to the other, it's just flipped, but let's go ahead and do that. So we're going to copy this view and mirror it. We mirrored that over. I'm lining it up right now just so I could slide it over about 150 inches or so to be off to the side. So let's see. Anything else? Anything else? Could also make an elevation view of the front too, which would be really easy to do. I'm just going to take what we have currently in our section view to do that. I'll show you how that can be done pretty easy. Whoops, on move, PR. Okay, well, it's fighting me there, but that's okay. So I'm using the move command, and I'm going to move this section view over here a tad bit. And we're going to clean this up too, just like we did with the other one. So what I need to do is replace this block with a 1.5 inch rectangle, just like this. That bracket is no longer going to be visible, but we are going to be able to see, connect the dots essentially. So we're taking a point in a rectangle to snap to this point, over to this point, take a rectangle from this point down to this point, and then a rectangle from this point to this point. All right, now anything in the middle is donezo. We're getting rid of it. All we want to see is the outmost lines of what we're drawing here. So we're removing all the die wall components, removing all the hatching, removing anything that you wouldn't be able to see because we're not cutting through this anymore. We're looking at it as if it's a side view of the table. So again, that's exactly this if we're looking at it from this side over here at this corner. So now that we have that, now we got all of our elevations, we got a section, we got details, and we got a plan. I want to make a horizontal section, but we're going to come back to that when we make the model. So we'll take a break here in between this session and the next, and we'll come back and we'll make a 3-dimensional model of the island. And then what we'll do is we will use that to generate a section view of the framing inside of it horizontally through. So we'll take a quick break here and we'll come back to this.